Yeah, go to console.cloud.google.com. And did I send you the email ID to login? May not be. You should have got an email. It will be from try cube training. Just the word, one word, cube train maybe. Cube train. Not even training. Yeah, try. Yeah, an account has been created. You have to sign in to this account. Okay. Why is that? But I need to give you the password for that. Even if you go there.
You need to log in with this email.
Correct. That is the one. Let us see.
I can just log out from here.
Yeah, log out from everywhere. And then you should be able to do that.
Right in 40 hours. That's what.
Or I'll just go to console.gcloud.google.com and log off from there. Yeah, so here I'll give you a password to log in. Try this password. I'll give you in chat. Yeah, this is the password. Yeah. Yeah, you can reset whatever password you want. Yeah, you have to go to GK. First, you have to choose the project. No, you need not. Just you can say dismiss, You have to, in the select a project, change it to the project which is Kubernetes, I think. In the top left, select a project. Top near Google Cloud Platform, right side of Google Cloud Platform.
Okay.
Yeah.
Yeah.
And in the no organization, change it to KubeTrain. Yeah. And choose KubeTrain project. Okay. Now you should choose Kubernetes engine left side below. If you come down, Kubernetes engine, yeah, clusters. Okay. So this is the cluster we are going to work today. Okay. So now the parts are not schedulable. Let me fix that. Okay, so now what I'm going to do is you can click on the KubeTrain dash cluster 1 and you will see this cluster per se. Okay, so now what I'm going to do is I'm going to, yeah, this will give you an idea about all the configurations of this Kubernetes cluster. Okay, so now as you have access to this, you can click connect, the button in the top, yeah, and run in Cloud Shell. Yeah, so here you'll get a shell where you can type the command, and you can also click on the open editor. Yeah, here if you want, type like kubectl space get pods, KUBECTL.
I think it's already come.
You have to press enter. You have to press enter now. Yeah, kubectl get nodes or pods, KUBECTL space get nodes or pods. Yeah. Okay, so you got a shell working. Now, yeah, I'm adding more nodes to this pool. That's why it says not ready, because it's only 1 second, right? Okay, now you can click on open editor in the middle of this page. Open editor, middle right side. Yeah, click on that. Click on that open editor button. Yeah. So here you can also enter file names and sorry, I mean, you can create files, edit the content of the files, and you can run it also. Okay.
Is it like an explorer?
In a sense, yes, yeah. You have to click that open terminal again, I think. Yeah.
Okay.
Yeah, okay.
No, it's still initializing. it opened up, then we'll go back to it.
No. Yeah, this and the other guy. Okay. Click on the open editor again. I just want to see that editor and
Slides.
this should not take so much time. Okay, so now all three of you are, hey, Rajesh, thanks for joining. Rajesh, you have access to this Google Cloud and all, right?
Yeah, yes, right. Yeah.
So Harish, so all of you have access now. Okay, so now,
Yes, yes.
super. So now what I would like to do today for the next 45 minutes is that I want to show you how to start from scratch. How do you create a Docker file and then build a Docker container? And then how do you create a deployment in the Kubernetes environment? Okay, so I will start sharing my screen now. Okay, let me know if you all can see my screen. See, I made some notes here. I'm going to share this detail to you all in this chat window so that you have access to this to follow just after I finish it. See, fundamentally, Kubernetes is a Docker container orchestrator at scale, right? So that is one of the definitions. So your starting point, especially from a developer's point of view, is to take all your code, either compile it and put it as a compile it and put it as a binary inside a Docker file, or if it is like interpreted files for Python or Ruby or any other interpreted languages, then you should have the interpreter and the files together so that your files will interpret it and then they're going to create or uh, like work where they're going to send your details outside. And if it is some sort of compiled application, then like Go language and all, then you can have your binaries and start them up. If it is statically compiled, or that's different way, right? So now today what I would like to show you is a very simple Docker file. Okay, just what 5 lines. Okay, so what this Docker file will do is, from Python, it's going to create a Python app.py. And then if you look into this app, here requirements is only Flask. And then this app.py just contains, it initializes this Flask application, and it's just going to have this message, demo Flask and Docker application is up and running. Okay, so this Docker file is going to have, just going to get the Python, the base container from Docker Hub, and then we are going to create, copy this file onto that, and we are going to start this Python process. That's all this is going to do. Okay, so now let us build this image or this Docker file, and I have actually most of these details here, like a sample run which I did earlier. Okay, so now let me see if I can Git clone this guy. HTTPS should work. Okay, to begin with, I'm doing a Git clone of this one. And here I have this kubetrain folder, and today we are going to follow this one. So this is where it is. And cat docker file. As you saw, this is what it is. And let us see if we can just use a VS Code just to edit it here. Okay, I have my VS Code here. Now you see we have this Docker file here. And this is the documentation which a sample run which I had, and it contains all the detail. So now, okay, these contents are ready. My first step is to log into Docker, right? See, there's lots of container repositories or registries. The default one is docker.io, right? So the step one is to log in to docker.io so that you can start pushing the code, right? Now I have an account by name Canada. That's my Docker account code. And I am logging into that. Oh, okay. The reason could be I should do sudo, I think. It would be better if I can do sudo for everything. Okay, let us do one thing then. Okay. Really? Okay. Let me try this from here. Okay. This I will do in few minutes. Okay. So let us continue with our documentation here. And see now, my first step is, let's assume I logged into this Docker registry. My first step is to one second, am I in the right place? Yeah, I have the Docker file. Edit, paste. Okay, so now I'm building this using this Docker file with this name of Flask 05, and it goes to the Docker IO, which is the Docker hub, with my name and with this my repository name. Okay, so I'm building it. Okay, sudo. Okay, so now if you see, this guy is downloading the Python, and then it is going to take my file and it is going to attach it or insert it into this Docker container. And now currently it is building it in my local computer, right? In my local laptop, the Docker container is being built. This is step one for anything, right? As you can see in the document also here, this I ran it earlier. And then theoretically, if I want, I can make this guy to run in my local computer just for testing purposes. Right, and I hope most of you would have already done this. Is there anybody who has not built a Docker container yet? Hey, Sachin, welcome. Anybody else recently joined? Okay, only Sachin. Yeah, so Sachin, what we started is I shared that link where I have the step-by-step document how to build a Docker container. Okay, so this command, it built a Docker container using this Docker file, and it also said this is the content of my application. Just says demo Flask and Docker application is up and running. So step one is I have to package this content of my application, whatever is the content. Obviously, this is just like a hello world program, but an actual code will be thousands of lines of code from the developer's point of view. Okay, so now we are starting from scratch. We don't have this thing. So now our next step is, see, this build is complete. Now I want to run it, and I'm running it in my local computer because this is just a development environment. I just want to see if it runs, right, and it gives me the intended output. Okay, see, now I'm saying Docker run in this port 80 because the application is also port 80, and this is the tagged image. Okay. Oh, sorry. Okay. Okay, so it is running now. So if I open a browser and if I go localhost port 80, obviously. Yeah. See, the Docker container is up and running. Please go ahead. Yeah.
A quick question, so you created the Docker image and you uploaded it onto the Docker registry, right?
Not yet. One second. Not yet. See, if you see, the only thing I've done is I have built this Docker image, Docker build -t locally. Step one is build with a tag. This is just a tag. I can give any tag, whatever, like my local Docker container. But then there's a purpose I've given here so that the upload becomes very easy in few minutes.
Oh, okay.
Okay, so I'm building it locally, but I'm giving a tag. Tag can be anything, right? But then because let's even go to this website here.
So the Docker IO here means nothing. It's just a tag associated with the image.
Correct. Okay, in 1 minute you will see how this is going to be used. Okay, so now I ran Docker also, and I got this application up and running locally, right? In my local host on port 80, it is up and running, right? You know what? Okay, so let us say, okay, now this is up and running. I've tested is fine, but then I want to make a change. Okay, say for example, locally, I want to do some upgrade. Okay, this is just version 0.5. Okay, I saved this file. Now, okay, now a couple of interesting commands are sudo docker ps. It shows the running containers. See, this is what we created a minute ago, and docker image ls. This will show you all the images in this computer. I've been testing this and all. So 3 minutes ago, we built this image, and 2 minutes ago, we ran this image all locally now. Till now, it's all local. Okay, so we built the image, we ran this image. Now let us stop this image. Copy, Docker, I think stop. I'm not sure. Okay, I stopped this running image. Okay, so if you see Docker image list now, sorry, Docker PS, there are no running image. Okay, now what I did is, this is just version 0.5, right? So this is update I made. Let's say developer comes and he makes some changes to his code. Now again, the developer is going to build it again. Let us say this is version 0.6. Okay, the Docker container version. Now, okay, sorry, instead of building, I did something else. Docker build, instead of 0.5, I want to call it as 0.6 because I made a newer version. And everything only I'm building locally only. I'm not pushed to the cloud yet. That will come step 2. Okay, so now this guy is going and this guy is rebuilding it. Generally, this time it is quicker if you have observed, because it is going to make use of whatever is the content locally which is available. So now let us build this Docker run 0.6. 0.6. Okay, you know what? Let's even see Docker image ls. List the images. If you do this, then you will see here there is 0.6 is also created 22 seconds ago, right? With a different image ID. So this is the older version. This is the newer version, 0.6. So we can run Docker run 0.6. Okay. Now let us go back to our this one. See, now here there will not be anything running because that Docker container is down. Like we deleted it. Okay. So now okay. So
Jay,
yeah.
Jay, for me, sorry to interrupt, Jay.
Yeah.
Like for me, the Docker like the 0.6 version, right? But still
Yeah.
it's showing us 6 minutes ago, like 5 minutes ago. Like I both are showing the same created.
Where?
Why did
Yes.
in the Docker? Yeah, yeah. You see,
No, this
yours
is
is only
22 seconds ago.
yeah, yours is 22 seconds ago. But I just created 0.6 as you are saying, okay, in parallel. But in my system, it is showing us 5 minutes ago. The reason is maybe I didn't change anything actually. I just
correct. See, if you don't change anything, this is intelligent enough not to make any change. Obviously, if there is no change, then it is going to be the same. It will not rebuild or anything. That intelligence is built in Docker. Okay, so now I made a file change and I'm a developer. I made the change. I'm building it again and I'm running it again now. Now, if you see, it should say this is version 0.5, right? This proves that my newer version is built here. Okay, so this is built. So now, okay, I'm a developer. I built something and I've tested. Things are looking okay. Now I have to push to Docker registry, which is shared by everyone. I mean, the centralized repository. Okay, so docker.io. This is one repository used by the whole world by default, unless you don't have your own company-wide repository. This is the central hub for every single Docker container. So this is what if, okay, so now this is the image .5 which I have uploaded for the testing purposes. But anyway, let us spend a couple of more minutes about Docker. See, Docker has got like millions and millions of containers are uploaded by everybody in this world in Docker. So if you click on explore, you can see like there is 8 million available images, which is humongous, right? And some of them are called official images by the company, like standard used by everybody. So you can trust these images because like there's billion people are using this Apache web server, right? So you can download any of this thing and you can run it. Like just for sample, I just want to take a simple one, and even here there the command is here. So any of these millions of Docker containers, if you want to consume it, it is going to be as simple as okay. Even before that, I want to show Docker image ls. Okay, so if you see here, there is no busybox Docker container here. Now I just type Docker pull busybox image. Okay, it will take, like, if you see here, it downloaded the busybox and I have it here. I don't know, maybe it was download. It was 12 days old. Maybe it was built. So the point only I'm trying to make here is that any of these thousands of containers, we need not start from scratch. We can just make use of this thing. Like you want to build a PostgreSQL server, you don't download and install, create a Docker file and all those things. Just say Docker pull Postgres and then you can start, right? Nobody's going to start from scratch these days, whether you want Nginx or Apache or Python, Redis, Nginx, MongoDB, Node.js. Almost everyone will use Node.js. This image, if you want to do any Node.js, MariaDB, traffic, Docker in Docker, a web server, RabbitMQ, Memcached, and a registry itself, and then Java, Golang, CentOS operating system, InfluxDB database type, and HA proxy, PHP, Maven, Ruby programming language, Tomcat, if you want to have any sort of Java, you can use that. And if this list goes on and on, right? So as you might have seen here, even when we are creating our Docker file, we are using Python. This Python is actually from the Python here in the previous page. When I say import Python, then the Docker knows it has to go here and download this Python. And after that, we are saying, okay, copy the files which are in this folder, which are all my customized file. And then I'm saying, start this Python app. So I'm also not, even though I'm starting my own Docker file, this Docker file imports a Docker container from Docker Hub, and then it will build on all this thing. And almost always, 90% of the cases, you will always import a container from Docker Hub, and then you will, onto this, you will add or add your code. That is how it is going to be. There are very rare scenarios where you will, create your own code and then statically compile everything. Okay, so what we have done is we have run locally and we have tested it. Now our next step, as you might have seen in my document here, so I pushed and then I built it here now, and I ran it and tested, and I can do curl localhost and it is up and running. Now my next command is docker push. If I do this command, magically this will go to the Docker Hub. Okay, let us try to do that now. But my problem was the Docker Hub wanted my password. Let us see if it works. Requested Docker login. I could not get the Docker login. Let us see. What am I missing to log into this Docker? And I request all of you to get a good Docker ID yourself. Surely, if you are working for a company, you will get it. But otherwise, if you want to, like, personally test and all, then you should get your own Docker ID. This had a problem. Storing credentials, Docker credentials, secret service. Okay, let us see if this works. This also did not work. Okay, see, I do not want to troubleshoot this now, but luckily what I did an hour ago was I uploaded this, right? By running this command. I just said docker push docker.io.canada flask 0.5. Right, and then it pushed it. Now, as you have seen, I tagged this container intentionally as docker.io/canada/flask:0.5 because if I do this, then this docker command knows, okay, it has to go to docker.io/canada. I mean, docker.io is the website and Canada is the username and Flask is the repository name it has to go. It knows. This is all predefined and pre-configured, right? So it goes to this docker.io and then my account. And now I've configured this to be publicly available, right? So this will be available to everyone. So this is what I've done. So this is like, public, it's a public view and I've uploaded. It is available for each one of you or anybody in the world. If they want to download this Flask, they can. And if you want, some of you can try it in few minutes. Does anybody have Docker client installed?
Yes, I'm also trying. I'm also doing the same one.
Okay, can you do this, please? Docker pull Canada/flask:05.
Sure.
Can you also share your screen so that everybody else also will get an idea? You have access to share screen, I think.
Yeah, but I think you need to stop.
Anybody else?
You need to stop this. You need to stop the.
Oh, yeah,
sharing.
sure. Okay, I stopped it. So, yeah. So
Same error. Pull.
That's okay. This is, can you do a Docker pull? Do you have that command?
Yeah, no. Docker pull, Canada. You're seeing my screen, right?
I'm not seeing your screen. No. Oh, yeah. Now I can see. Yeah. Docker pull Canada/flask:0.5.
Already exists.
Yeah.
Download a newer image for Canada Flask 0.5. Yep.
Right. Maybe because it is built by you.
I also built it. Yeah, built by.
Correct. Okay. You can remove it if you want and you can download it. Anybody else? Any other volunteers? Okay, if nobody else, also not a problem. I would like to continue here. Okay, so now what we did is we created this Docker container locally. Actually, a CI/CD pipeline will build it, but then that I want to show you in the next class. Now let us say I've built a Docker container and I put it here in the Docker Hub, which is globally accessible. Okay, so now what I should do is I need to build it, right? So what I would like to show you here is, if you go here, build Docker image is completed now, right? So I have a Docker file, my Docker file is updated. It's in GitHub for now, but it can be any other registry. Now I want to deploy it. Okay, so now the Flask deployment should work. So if you see here, what I'm saying here is my image is this image. Okay, so if I deploy it, it is going to run. I need some other volunteer to deploy this. Anybody else? I mean, as you have access to the Kubernetes cluster, you just need to copy paste and run this command. Who would like to do this?
I can do it.
Awesome. Thank you very much. Please, I'll stop sharing and I will share this link to you all so that all of you can follow this. Okay.
Let me share my screen.
Awesome. Okay, go to console.cloud.google.com. Yeah, and log in with your kubetrain ID. Go to GKE, yeah, clusters, and select our cluster. Okay, yeah.
My internet might be a little slow.
Oh, I see. Okay.
Maybe if somebody else wants to do, they can do it as well.
Anybody, any other volunteer?
I can do.
Okay, go ahead, take control.
Let me stop sharing.
Kubernetes engine. Yeah, you can pin that.
I don't know.
Mm-hmm. Yeah, click connect. If you want to go to deploy, that is also a choice.
Okay.
Yeah, open editor.
Open editor.
Yeah.
In
No.
local.
No. You know that you see editor just about this black part of the screen. Open editor. Yeah, file new, and you can go to my repository.
I copied it.
Okay,
I think.
where is it? Can you copy paste the first file? Yeah. Okay, so now let us go through this file. So what we are saying is this is of type deployment, and the name is Flask Deployment, and the namespace is going to be default, and the label is going to be app:/Flask. So that is how this will be line 6 and 7. Right, the label is app is Flask, and line number 9 says there should be 3 replicas. Okay, and then the selector is this application. If anybody has got a label of app is Flask, then this application will be selected. And in line 19, the name of this container is Flask, and line 20, the image either you can have in that format, or even if you can just say Canada/Flask/ I think it is repeated. It's most probably not going to work.
No, it's commented. One line is commented.
It's commented.
The second part
No,
is
no.
commented.
Even line 20, I think it's mistake to have Flask twice. Can you remove one of those flasks, the middle one?
Flask. Oh, okay, that's it.
Yeah. Okay. Save this thing, and then we are saying port number 80. Okay. Yeah. Save this and run from your command line. Go to run terminal. No. Left side. Not that. Can you go back? Open editor. Same thing. Yeah. In file, edit, selection, view, go run. Yeah. New terminal. Yeah. kubectl apply -f. And first deploy. Yeah. Generally, you should have .yaml as the extension, but it is okay. Even without that, it will work. Okay, go ahead. You know what? Control C. Okay, no problem. Just kubectl get pods. I just want to see there is no pods of the name Flask Deployment. Kubectl get pods. You know what? Let's do one more thing. Type kubectl get ns. Okay. Do you have your namespace? You don't have. Okay. kubectl create ns Praveen. Okay. Up arrow key twice. You should see a namespace by name Praveen, right? So in the file above, go to line number 5 and change the namespace from default to Praveen. Okay, so you created a namespace and you are configuring this guy to be deployed there. So again, type kubectl get pods -n Praveen. Get pods space -n space Praveen. Okay, so there are no pods here. Now go ahead and deploy this thing. Kubectl apply. Yeah. Okay, created. Up arrow key twice. Enter. Okay, so the containers are being created. So this guy will go and it will download dockers.io/Canada/flash:0.5, that version. It will download and deploy. Okay, can you enter? Yeah, keep trying this command. Container creating. Okay, it should not take so much time. It could be as simple as
It's running.
Oh, it's running. Sorry. Okay. So your containers are running in the namespace of Praveen, and it is 3. Okay. So now the second thing is go back to the repository and copy paste the other file also. Yeah. So now we are creating a service. What this service is saying is it is of type cluster IP. And yeah, go ahead, copy paste this file. I mean, create a new file called flask-service.yaml. and copy paste and change the namespace to the other service, whatever you had. Okay, so now here what we're saying is we should create a service with this name in this namespace on port 80, obviously, because the application is running on port 80, and expose it also on port 80. Target port is the pod's port, and exposing it also port 80. The port 80 in line 11 can be anything. Okay. Wow, this guy is giving like help and it is type cluster IP. Okay, so deploy this also, Praveen. Okay, kubectl get service -n Praveen. Okay, so we got a service now. It was created 8 seconds ago. Now we have to expose this service so that we can view this. And let us see how we can expose this, because that is the very interesting thing. Going to the service of Flask. Kubectl. Okay. Port forwarding. Okay. Okay, Praveen, there are multiple ways to do this. Give me a second. I will give you a command. Port forward. Okay, let me give you that in this chat window. Okay, you need to try this command, but you should use one of those 3 pods. I'll tell you the command if you want. It's easy. Can you start typing kubectl space port dash forward dash n Praveen, or you have to type dash namespace, only one dash n space Praveen, and the pod name. You can copy paste one of those 3 pods. Yeah, I'm not sure how copy paste will work here. Okay, looks like it's working. Awesome. Space 8080:80. Enter. Okay, open a browser and copy paste that 127.0.0.18080. Yeah, or you can click. Yeah, try click or whatever way. Can you believe that? Our application is up and running now, and which on a Kubernetes cluster. So we started from Docker container and we have this application up and running, and it is running as a service. Okay, any questions now? Go back to the previous screen. Sachin. Yeah. So from here, this is a workaround. We can also make it as a load balanced externally available service, but this is how a developer is going to test. Okay, so if this comes, then developer is happy. Okay, is pod is running on a Kubernetes cluster. So now we can spend few more minutes if there is any QA. Else, I want each one of you to practice this and create your own namespace and get this up and running. That is the exercise for the next 30 minutes ish. But before we start this hands-on, Does anybody has got any question?
I have one question.
Please. Yeah.
Say now
Hmm.
we have two different services which we have created, and those two are talking to each other, and some certificates needs to be created so that it communicates with each other. So when we are
Okay.
creating in the image, Docker image,
Yeah. Correct.
how do we provide
have-
those certificates so
Okay.
that it is secured only for the organization, not for any other?
Okay. See, this is a complex topic. There is a step-by-step approach, right? So that at a multiple levels, you can embed the certificate of the company to be distributed, so that all communications happens in an encrypted way, right? So that will come in subsequent sessions.
Oh, fine. Yeah.
Right? How to embed the certificate? That documentation is there. We can practice it later, and whether it is done, whether the encryption happens at the load balancer level or internal to the cluster, those things we will talk. Okay, but one thing to keep in mind is inside the Kubernetes cluster, you don't need encryption, because the Kubernetes cluster itself is considered to be a private, safe environment where only a pod can talk to another pod. You don't need an encryption. Only from user to the load balancer, and from load balancer to inside the service, if somebody is coming, then you need all encryption, certificate management and all those things. But then if one service sitting inside Kubernetes cluster want to speak to another service, generally you don't need encryption, but it is optional to have it. If it is really a sensitive application where you want to control it as tightly as possible, then it is better to have that internal, and that also you can implement optionally. But then generally, most of the application, if application one is inside Kubernetes cluster, it want to talk to another application which is also in Kubernetes cluster, then you don't need encryption per se, right? But it's optional. But encryption is mandatory for the outside world. If somebody types www.kubetrain.com, then from that browser till it comes to the load balancer and till the service, encryption is needed. But then when it comes inside, and then if it speaks to multiple other services, then it's not hugely important to encrypt it, but you can do that optionally. Okay. Any other questions?
Yeah. The other question, sorry, probably some other person has a question.
Go ahead. That's okay.
Yeah. The other one is, say, when we use this particular from Python,
Yeah.
are we guaranteeing that our application is compatible for all the versions of Python, or is there anything that we need to take care so that we always make sure that our application is compatible? Because if I guess from this it will fetch the latest Python version from the Docker to create this image, right?
Correct. Latest, yes. Whichever version. So, okay. See now, Praveen, when you're creating this image, right? Let us say on November 8th, you're creating this image.
Yeah.
Okay. Now, whatever the Python version came, it is going to stay here.
Okay.
With your image. Even for
Okay.
the next 10 years, you use this image, it is fixed. It is like baked inside that. It's not going to change, because your base image and all your content and the files and everything is working fine, is proven in your laptop.
Okay.
This container, if you upload it to a registry, and then if million people use it, and whatever is going to happen, that version of whatever you have embedded inside, it is going to work exactly the same way everywhere for the next 10 years also.
Okay.
But 6 months later, when you download this Python, let us say Python version 10 has come. At that time, it might break. But then in the development environment itself, you will know, oh, this is broken. And then you will rewrite your code and then you will send it. But it is a good practice to say from Python, say 3.7, from Python :3.7 or whatever version is there, that specifically also you can download, so that even if you give this Docker file to your friend 5 years later, when she uses this Docker file to build, then as it is defined from Python 3.7, then it's going to download 3.7, which is exactly the same, because even after 20 years, the Python 3.7 is not going to change.
Yeah.
That container, that exact container. So this is how you manage this thing. So this is the whole point of write once, run anywhere millions of times, whether on-premises cloud, on Docker container, public cloud, your friend's network, your friend's company, wherever it is going to work. This binary, this Docker container will work exactly the same way, because it is like a binary. Right? Nobody's going to change the content inside some files. They are not going to edit. This is the final, unchangeable, immutable.
Okay.
Right? So that is the advantage of Docker. If it runs in your laptop, it will run for the next 10 years wherever it is run. Exactly the same way. Right? That is guaranteed.
Okay.
Right? And if you have any garbage or unnecessary files and junk files and irrelevant files, that will be carried for the next 10 years with this container. So be careful. Don't use junk files or unnecessary files. Whatever you're going to build, wrap it around. Be cautious. Don't have unnecessary files, because next 10 years you give it somebody else uses it, the server is running in a server, and your whole company uses it. It is all going to be there exactly the same, immutable.
Okay.
Thank you.
Yeah. Thank you.
Okay, Sachin.
I'm not able to. The Cloud Shell editor, it's still initializing.
That's okay. That we will troubleshoot that later, Vasant. Anything else?
So how to
Log off, log back in, refresh. It has to work.
no. Oh, that's okay. But okay, but I will do it. To deploy these two things, right? Like the workspace you created, like how to create the workspace. So I thought it's an open editor. Kind of creating the new file and deploying it, right?
Vasant, your audio is not very clear.
Okay. So
wait, before getting into action, do you have any question?
No.
Okay, we will come to troubleshooting part soon. Anybody else? Rajesh, Harish, Sachin, any questions?
I have a question, Jaram.
Please. Yeah.
So what we did just now is basically you forwarded the request to the service, right? From the, like, because we have a Flask deployment YAML and a service YAML. I might have missed the starting part of the session. So I just want to understand the flow here. So from the deployment where we pulled the image from Docker and deployed it, what is the service doing exactly?
Okay. Yeah. Let me see if I can get this with some example. Give me a minute. Expose service. Okay, I'll share my screen now.
Okay.
Okay, so we have a service by name Flask. Let me see if this command can work. Okay. -n Praveen, I think. Expose. I think it should be app. Give me a minute. It's a very simple command. I'm looking. Expose. Expose deployment.
Is it port forward, Jay?
No, I'm not looking for port forward now. Deployment Flask. Port 80. Type load balancer. Okay. Deployment. This. I think this. Not sure if it is needed. I'm giving the namespace correct. Let me see. Get deployment. Flask dash deployment, is it? Okay. Okay, now this guy is trying to get an IP address. Let us wait for a few minutes. I'm going to delete this unnecessary load balancer. Front end, because it costs us money, right? I think this load balancer something like 10 cents an hour or something like that. Okay, so now this Flask deployment which I had, I created a load balancer here. And it gave me an IP address, this one on port 80 itself. See, okay, it's working. So now my request to each one of you is, I'm going to share this thing, and please let me know if each one of you can access this. And if you want, from my curl also, I can access this guy. While true, do curl.
Yes, it works.
Sleep one. Okay, if you see this
Yes.
command, I'm saying every second do this curl. And let me also do a date. Okay, curl. date, curl date, curl date. So this is curling the application now from the internet, from the public internet, because of only one magical command, right? This command I said kubectl expose deployment, Flask deployment, which is running on port 80, and make it to run on port 80 and type load balancer. I ran this command. Now whole world can see this application. This is the power of Kubernetes. Okay. Now let us go back to Sachin's question. Sachin, if you don't mind, can you ask that question again?
Yeah. So
Okay.
basically, I just wanted to understand what is, I mean, the purpose of service here. Once you deploy the application is
Correct.
already live, right?
The application is live. Correct. See, inside the Kubernetes cluster, the application is up and running. Correct?
Right. Yeah.
Okay. So now this is where the abstraction comes into play. The abstractions. Okay. So this is what Kubernetes is. This is what Google did. What Google did is it gave you this abstraction called services. Okay. If you let me go, where is that session we had? Manage, provide native methods of service discovery. Okay, that is the terminology which we have. Else, okay, see, we created a pod and we deployed it. So this compute is up and running. But then how do you access this service from outside the world? And internet is a very, very scary place for us to go, right? I mean, hackers are there. Any unpatched machine in the internet, I think in few seconds people will hack it. Okay, so some of the abstraction you need to know are this services is the idea how from the networking point of view the application is exposed. Okay, and there are 3-4 types of services which we have. Let me go back to that page. One sec. I'm not sure where I had that file. Let me check again here. Okay, looks like I don't have that particular image. Okay, give me a minute. Let us do that. Client cluster IP. Okay, this is one simple image. I believe we can use it. Okay, so now, Sachin, okay, we have worker 1, worker 2, worker 3 node, and my pod is running. Internally, it is happy. Okay, and how do I expose for the world to see this? Step 1 is we have to create what is called as a service for each of this one. And as you might have seen, the Flask, so let us go to this workload. So that is where the details of this the labels come into picture. So now what I did is when I did a deployment of this Flask, which with my Flask application, I had a label called app::Flask or application equals Flask. This could be any of this 1000 name. Okay. And then when I created a service, in the service also specifically I said, right, this is, I think this is where I created. I specifically said app equals Flask. Okay. And then I exposed this to the internet. Now, when I expose it to the internet, like from the load balancer, now the load balance from the load balancer, when it comes, I'm saying in the load balancer, the deployment is equal to Flask, and deployment equals Flask means the app equals Flask. Okay, so then when this request comes here, it comes to service, and then the service. So this networking, there are multiple ways how you will configure, but then all the services and the deployment is based on the labels, right? So I have a label here called app. This app is equal to Flask. Then I created a service called app equals Flask. So anybody uses either from port forwarding or from a node part or in the cluster IP or load balancer from the outside. If anybody enters this Kubernetes cluster, and if they after entering, if the service have got a label of Flask and this deployment has got the label of Flask, the request will be sent here. This is how the services work, which we will see in the subsequent classes. That is the next topic. But in a very high level, this is how services work. I mean, this is abstracted. This is actually hugely complex topic. Like I have maybe 10% of this understanding how the networking part of this works, but then we need not know about it, because as you actually saw, it is just enough I type this command and magic will happen in the background, right? And it is just enough I create a service with 10 line of YAML files. As you can see, like, okay, let's even see what Praveen created. If you look at this YAML, it is just 10 lines of simple YAML file. Okay, so this guy is giving me from here. Right, so I just said label is Flask, and I just said select if app equals Flask, and it is of type cluster IP. If I say this, Kubernetes does complex magic behind the screen, and your 10 lines of YAML file does all those magic for you and make it work. That is Kubernetes. You need not worry, okay, how does this route? What happens if this pod dies? What if I have only 2 pods? And it will do. Like, for example, even let us go back to this workload of Flask, which I deployed earlier. Okay, I think I did it in default here. Okay, so now I think I had 3 pods running. Okay, 4. I think I have 4 pods running. Let me scale it down here. Okay, auto scale. No, not auto scale. I want to scale it down. Okay, cancel, scale to say only 1. Okay, now can you all please go and or even my curl command. See, my curl command is running. I'm still getting this file continuously, and there is no disruption yet. And if you see here, I have only 1 part running. So Kubernetes knows, okay, 3 parts are dying. There's only 1 part is running. So I should send all those requests to only this pod, because the other parts are dead for whatever reason. And now Kubernetes is doing all the magic of network routing. Okay, now these 3 guys are gone. I should remove these 3 guys. There's only this guy. So I should route the packets which is sitting from some other part of this world only to this pod. All those humongous complex TCP/IP routing and firewalling and packet mangling and packet routing, all Kubernetes is doing in the background. We need not even worry about it. See, my application is still up and running, even though 3 of my parts are gone. Right now, the same thing I can do. I can scale up to 5. Sorry. Did it? Okay, I just edited, right? So Kubernetes is doing lots of complex work behind the scene just to route it. Okay, now I have only one pod, okay, but still my requests are running. It did not stop at any point in time. Okay, this is complex networking is happening. It will take 10 PhDs to comprehend and understand all these, complex things happening. But they've abstracted it all. They have simplified it to us. We just need to write a 10 line of YAML file which says, okay, service anywhere the deployment's label is equal to Flask, then send this requests. Right? See, I have only one. Now let us scale it up. So still my application is up and running here. The requests are, you know what? Let us scale down to 0. Only then we can prove that, that this is what is sending the loads, right? Was it in actions? Yeah, scale 0. See, immediately you saw this failed. So I'm not lying. This is the actual application. I scaled it to 0. Now nobody can access because 0 is like meaningless. I mean, technically you can have 0, but then you don't want to have 0. Okay, now let us scale this guy to say 2. Okay, now you watch this right guy will become healthy because see, it's a Docker is application up and running. If it is 0, obviously there's no pod. I mean, there's no request is going to come. But then when there are 2 pods, immediately in a split second, you saw it is up and running. Now I can have 2000 and I can upgrade. If anybody can push it, the tag. Okay, if I put the tag to 0.6, right, then technically I can do that. I can upgrade it to 0.6. To upgrade to 0.6, it is as trivial as coming here and editing this file to 0.6 and then saving it. The application will be upgraded. Okay. Any questions?
So, Jairam, just a follow-up
Yeah.
question. So I got
Sure.
the idea of service.
Correct.
So the last command that you ran, so
Yeah.
with that, you basically created a load balancer for that service.
Correct. For the external world to come in.
Okay.
Internally, see, by default, okay, as you have seen here, there are at least 4 types of services you can create. Services itself are 4 types. By default, it is a cluster IP. Cluster IP means this IP is available only internal to the cluster. Outside people cannot access this because this is for internal communication to happen. One application want to speak to another application. This API want to speak to another API. Only that scenario, you will have cluster IP. Okay. Node port is you want to expose it in each of those node which is running, and then you can have a load balancer or whatever way you want, or you can expose it in each of the compute node. And then comes the load balancer. Cloud provided ELB. This is what I did of type load balancer. That's what I had it here. See here, type load balancer. When I type load balancer, then it is an actual virtual load balancer where millions of people can access it, and it costs 10 cents an hour. This cluster IP is free because it is internal to the Kubernetes, but then this millions of people can access it, 10 cents an hour. I'm exposing it to the internet, and this is very well protected. This load balancer is intelligent to send to the service only, right? So it's an integrated load balancer given by Google Cloud for this GKE. With one command, I can setting up a load balancer, and this load balancer is intelligent enough to go to the service and send it and bring it back. And then all those things it will do using node port. And even if this whole node shuts down or restarted, or if this pod restart, at a node level, if any of these nodes shuts down, this load balancer is intelligent enough not to send to that node, compute node. So that is what
Okay.
this guy does. Right. So there are 4 types of services. So as you see here, all of networking stuff are abstracted as services and ingress. Okay, that we will cover in the subsequent sessions. But this is what it is. Kubernetes abstracts everything for you. In 10 lines of YAML, you can get a deployment. In 10 lines of YAML, you can get your application up and running to the whole world outside. Right? And then you have storage where you can add disks for whatever persistent storage you want to have. All those things will come subsequently. But then today we covered how to create a Docker container and put it to your registry and add that line onto your Kubernetes, add that line in your deployment and expose it. Right? So this is what Praveen created, and it is just one line, as you can see in that YAML file. The image definition is done in just one line, and obviously you have port numbers and all those things coming. Please show me the YAML. Oh, it's here. Okay. Why can't? Oh, yeah, this is what I thought. Yeah, I can edit the YAML file here itself. So here in this deployment, if you see, it is just this trivial one line. It goes to this docker.io and the folder Canada /Canada/Flask and downloads it and then starts it and then does whatever is required. Just one line. Right. So developers create this immutable containers, and then it comes to the Kubernetes and then auto scaled and is exposed in the internet for millions of people to come and consume it. Okay, so that's what today's focus is. Okay, so then we can, that's what I want to cover. It's 8 o'clock here, but I'll be happy to stay and ensure each one of you completes your homework. Okay, now preferably. So as we know, Praveen has done this. Who else needs to do it? You can share your
Jay,
screen and yeah.
I
Good.
that deploying those 2 files I have done.
Super.
Yeah. So apart from
If you're
that,
deployed, if it says running, then it is good.
let me share my screen. 1 minute.
Please. Yeah. Okay, your deployment and a service. Oh, super. Okay, click that guy. And if it comes in a browser, you are successful. Click plus control plus click to follow the link. Did you open this in a browser? Is it open in any other window?
Yeah,
Or
it's
you can
loading.
copy. Yeah, okay. Yeah, so it is up and running from without even exposing to the internet. So this kubectl port forward, what this command does is, it's actually a hugely complex command. What it does is it creates some sort of VPN and connects to your laptop or wherever you're typing this command kubectl, and then it punches some firewall holes into the Kubernetes cluster and exposes it. So this is a poor man or a developer's way of looking looking into a service which is running in a Kubernetes cluster without doing any networking, without exposing it to the world, right? This port forward does it. Port forward goes to your Kubernetes cluster and exposes this port and the application to wherever this kubectl command is running, and it is visible from a browser or any port you're configured. So this is successful. What's your question, Harish?
No, I'm good. Yeah, I'm good.
Fantastic. Happy to know this. So this is how developers should test. Okay, they should not expose it to the internet and then test it from a browser yet. Okay, test it local in your local computer, obviously, step 1. Then test it by deploying to your Kubernetes cluster and then doing a port forward command line, step 2. Step 3 is deploy it in a pre-prod environment where somebody would have set up a port to be exposed with a domain name like testing.mywebsite.com, and then you will test it and then load test it and then functionality test it, and then the same YAML file will be deployed into production. Right? This is how the whole flow happens. Okay, anybody else?
Okay, I'll stop sharing.
Thank
But
you.
it's good for the Docker thing. I'll put the VMware workstation and the Linux CentOS.
Sorry.
No, for the Docker part to create the Docker build image, I'll have to do my setup. I'll have to do my setup. Yeah.
Correct. Yeah, to build Docker, you need one, or else I think next session maybe I would like to share how to build Docker in Docker Hub, or you can have any other CI/CD tools to build your Docker containers.
Yeah.
Okay, super. Any other questions? Anybody else need any assistance to build this?
Jay, like still
Yeah.
the Cloud Shell is not working.
Okay.
I did the logged off and logged back in, but still the Cloud Shell is not
Can you share your screen, please?
working. I tried to without Cloud Shell like
Okay, this is.
terminal
Did you?
just logged off.
You know what? Wait. Okay. See, at least you have a shell, right?
Yes.
Do you know how to use VI? Edit using VI?
Yes.
Okay, then you can edit the files there. Yeah. So VI space whatever YAML file you want, deployment.yaml, or yeah, deployment.yaml, and you can copy paste. Yeah. Control A, copy VI whatever Flask deployment file. I for insert and paste. Yeah, sometimes this happens. Then you have to do cat, that EOF. That is another way of doing stuff, which I know. Okay, else you want to, yeah, just escape Q, yeah. Okay, let me tell you that command. You know, cat greater than EOF. You know, you can Google how to do that, or I can also Google it for you. Cat greater than, less than symbol EOF, and then you close it to a file. Yeah, yes, you can copy paste that. Yeah, copy paste that, the whole line. Yeah, whatever you want, and then change it. Copy, paste, remove that guy, and replace that file to deploy.yaml. Yeah, now copy paste again whatever the content of the file. Yeah, type EOF, enter. Yeah, now cat that file. Okay, you got it right. Now you can use VI to edit that file. Did you change the namespace?
I didn't create this.
You can use VI now to edit this file, to change the or change the deployment name to Flask Deployment 2. Line number 4, the name of the deployment, you can change it to Flask Deployment 2. Yeah, not a good idea, but then it's a.
Why we are doing this?
Sorry, this is a different deployment.
So though we already had the same deployment of the name, so we are just doing a different deployment, right?
Yeah, yeah. Change the name of the deployment
Okay.
and deploy this one. Yeah. Save and exit.
I didn't get the namespace.
No. All those things can stay. Yeah. Kubectl apply -f deploy.
I didn't get the namespace, right?
No, you are deploying in default only, right?
Okay.
Kubectl apply. No, apply -file -f space deploy.yaml. Yeah. Now type kubectl get pods. You should have this error image pull. Oh, that flask was there. So VI and remove one of those flasks. VI to that file and that image name, right? It's a typo. Okay. Anybody else has got any other questions as we are troubleshooting this one? Yeah. If there's no other questions, then we can end this. Yeah. Save and exit and deploy it again. Up arrow key. Yeah. This should work. See, error image pull. It could not pull the image because that image doesn't exist. Up arrow key again, couple of times. Yeah, all running. Deployment -2.
What is this deployment -7?
That was mine. That was mine 15 minutes ago. Yours is -2. Now, if you want, create a namespace, kubectl create ns your name and go back to the file and edit it, and then you can do it. Okay. Create ns space whatever you want. Yeah. And edit that deploy file, and wherever it says the default, change it to the namespace only to that, and deploy it again.
Sure. Just one.
That's it, nothing else. These things can stay.
So then if I do this, like apply of, then that's it.
Yeah.
What happened to the one that is running in the default namespace?
That will run in default. You did not do anything for that. Get pods -n. Your namespace you should give. Yeah, this is what it is running from the past 14 seconds. They are also running. These are also running. Okay.
Okay, I'll start it.
Sure. Anybody else? Good for today?
Hey, one quick question.
Yeah.
When we are trying to port forward, right?
Yeah.
So it says the namespace, our namespace, and then pod name. That's what it says, right?
You have to port forward. Yeah. So what's the question? The format of the command?
Yeah. My question is, here we are specifically giving a pod name instead of
No. In port forward, we gave a deployment.